Secondly, we can look at each independent variable separately. The p-value gives information about the significance of the coefficients. A coefficient is statistically different from 0 when we can reject a null hypothesis at 10% significance level. This means that the p-value has to be smaller than 0.1 to reject a null hypothesis. However, coefficients cannot be interpreted because they are in log-outs units. Only their signs can be interpreted. Furthermore, for each model, cuts are computed. A cut can be defined as an ancillary parameter to define the changes among categories. In the paper of Antonio Afonso, it says that the rating agencies have several cut-off points to draw up the boundaries of each rating category. Using linear regression, different statistical interpretations are available. First of all, we can look at the general model. The Fisher test is used to determine if at least one coefficient is different from 0. The reasoning of this test is the same that the LR chi-square explained for the other probability model. The adjust R squared represents the explanatory power of our model. Adjusted R squared is better than the R squared because it adjusts the explanatory power of the model paying attention to the independent variable. It is possible to compare the adjusted R squared between two models if the independent variables are the same. Secondly, we can look at each independent variable separately. We kept the same criteria that in the other probit model to determine if a coefficient is statistically significant, p-value under 10% level. Moreover, in a linear regression, it is possible to analyze the value of the estimated coefficient contrary to in the other probit model.
We will now analyze the results. It's important to keep in mind that all analyses are made with an independent variable expressed in groups. Remember that the first step consisted in estimating the rating for Moody's and S&P with an ordered probit, making a difference between developing and developed countries. For the models of S&P, we notice that the variable GDP growth rates and political have not a statistically significant power to predict ratings in both models, developing countries vs developed countries. That's why we removed them out of our regression. For the models of Moody's, 3 variables were not statistically significantly different from 0: GDP growth rates, default, and political stability. We removed them. After these removals, for S&P, 2 variables appeared in both models: GDP growth rates, GDP per capita, and government debts, to be statistically significant at a 10% level to predict rating. For Moody's, the variable unemployment appeared to be significant both for developing and developed countries. In total, for S&P, 6 variables were significant for developing countries and 3 variables for developed countries. In total, for Moody's, 3 variables were significant for developing countries and 4 variables were significant for developed countries. We can now analyze the pseudo-R-squared. Both for developing and developed countries, the pseudo-R-squared for S&P is higher than for Moody's. This result is not a surprise for developing countries because S&P's model includes more significant variables than Moody's model. However, to predict ratings, models of S&P for developed countries include fewer variables. It leads us thinking that perhaps Standard & Poor's gives higher rates to this significant variable, or that it includes fewer variables for its rating process than Moody's in order to give ratings. We also underline that pseudo R-squares for developing countries are smaller than for developed countries. We can make the assumption that it's more difficult to have information about developing countries. We can now analyze the signs. All signs of significant variables have the opposite signs compared to what was expected, but it could be explained by our numbering of rating groups. We will give an illustration of this. The rating AAA corresponds to the class 1, whereas the rating AA+ corresponds to the class 2. Increases the rating means that we move from AA+ to AAA, but in point of view of classes, it's equivalent to moving from class 2 to class 1. In other words, rating increases when the class is lower. However, we have to underline that there is an exception. The variable corruption has the expected sign in both cases. It's due to the fact that the class 1 of rating has less chance to be associated with a high level of corruption. We can now analyze the estimations of rating. We took all coefficients of statistically significant variables and we placed them in the equation. After, we determined to which cut the predicted return rating belongs. It was then possible to compute errors between groups of rating. When the value of error is under 0, it means that the model underpredicted the rating level, and when it's higher than 0, it means that the model overpredicted the rating level. For S&P, the differences between the estimations and observations are comprised between -2 and 1. The average error for developing countries is equal to -2.239, and for developed countries, the difference between observed and predicted groups of rating is equal to 0.212. As you can see in the table, there is no huge differences between observed and estimated ratings for both developing and developed countries. For Moody's, the differences between the estimations and observations are comprised between -1 and 2 for developing countries and between -2 and 2 for developed countries. The average error for developing countries is equal to 0.1522 against -0.2727 for developed countries. To sum up, the interval of computed error is quite similar for both agencies. However, the average error are opposites according to developing or developed countries. Moreover, for Moody's and for developing countries, you can observe that there are less countries in class 5 and more countries in class 4 with our model than observed in reality. For developed countries, there are less countries in class 1 and more countries in class 2 with our model compared than the reality. If we compare the table of S&P with the table for Moody's, we can think that both agencies take different factors into account for developing and developed countries. Moreover, Moody's makes a higher difference between developing and developed countries than S&P. Remember that the second step consisted in estimating the influence of the rating, given by Moody's and S&P, on the interest rate for developed and developing countries. We used a linear regression with a sample of 53 countries, or 23 developing countries and 30 developed countries. This sample is smaller than in the first step because we found data on the interest rates only for 53 countries. Moreover, at least one coefficient is different from zero and so has an impact on the interest rate. For S&P, the ratings for developed or developing countries are significant at a 10% level. For the developing countries, we can see that the impact of the rating on the interest rate is higher than for developed countries. We have to test if this difference is statistically significant. To do that, we choose a Fisher test. This test confirmed this difference at a 5% level. Now for Moody's. The results for S&P and Moody's are quite similar. Now, the limits of our study. The most important problem we faced concerns the availability of data on internet. Lots of countries, majority developing countries, have at least one missing value for one variable. That's why we did not consider them in our datasets. Moreover, it could be interesting to consider also the agency Fitch, but there was too much missing values. For this reason, we decided to consider only the rating agencies S&P and Moody's.
Now to conclusion. The variables taken into account by rating agencies when they give a rating are part of an opaque methodology. We have now more information on the topic. With our study, we made some conclusions. The first step consisted in determining rating for S&P and Moody's for developing and developed countries. We highlighted several relevant things. First, the two rating agencies do not take into account the same factors for developing and developed countries. Second, Moody's seems to make a higher difference between developing and developed countries than S&P. The second step consisted in predicting interest rates according to our previous results. Our research question was, are OECD versus developing countries paying the right price premium, assessing ratings from credit ratings agencies? We can notice that the impact of the rating on the interest rate is different for developing and developed countries. Specifically, we can see that the impact of rating on the interest rates is bigger for the developing countries than for the other ones. Therefore, we can expect that the rating agencies pay attention to the status of the countries developed versus developing. This means that developing countries pay a higher premium compared to developed countries for the same cut level. The bibliography. Merry Christmas to all of you. Thanks for the attention.